Thank you so much. So we only have 5 minutes to talk, so I'm going to do my best to stay within that time frame. Oops, I'm not going to the next slide. Go. So just to give some context where we are as an agency, this is a hierarchy of LLM-based systems. So from the bottom up, you have just regular Q&A, single prompt, get an answer from the model. Next up is actually utilizing chatbots where you have a conversational history and are able to query the models and have them give you additional information with your context, with your history as context. And then above that, you have retrieval augmented generation, which is what we've spoken about here multiple times. And we're currently having some good success with that at DTT. And above that, you have agents, which is where the models start actually making some decisions themselves and being able to answer questions with that retrieval augmented generation information. And we're having some success there as well. And then on top of that, you have large language model OS, which is basically where you're directly interacting with the computer and working collaboratively to accomplish tasks. And we're not quite there yet. We're currently here, but I've seen some interesting projects in terms of the LLM OS style working directly with the models, but we're not quite there. So after ChatGPT was released at the beginning of last year, we started playing with it to see how we could use it to answer toxicological questions. And then when GPT-4 came out back in March, we got really excited with its capabilities. So this paper, ChemCrow, was released last year in April. This is a tool that utilizes LangChain, which is a Python-based LLM framework, to answer chemistry questions. So this kind of falls in that same space of retrieval augmented generation and agents that I showed on the previous slide. So after we saw that ChemCrow project and what it was capable of, we started the ToxPipe project to use LLMs to explore toxicological data using cloud resources and retrieval augmented generation. We wanted to do stuff like analyze and interpret toxicological properties of various compounds. And we really wanted to be able to enable scientists to explore diverse types of toxicologically relevant data through natural language instructions. There's so many data sets that were previously challenging to access and integrate into toxicological characterizations, but we think that by guiding the language models with prompt engineering and human-in-the-loop monitoring, that toxicologists can use these tools to rapidly find information on chemicals and dramatically reduce the amount of time required to do so. So some of the data sources that were already incorporated into ChemCrow included PubChem, PubMed, Semantic Scholar, and RDKit. And during an NCBI Codeathon back in March, we entered ToxPipe as a project there, and we're able to re-implement some of the ChemCrow tools. And we're also working to implement other data such as EPA CompTox dashboard, NTP technical reports, and other internal toxicological databases. So I have deployed an internal web application called LibreChat for use at NIHS for the interactive portion of this project. It's a free MIT open source platform, and that takes inspiration from ChatGPT. I'm sure many of you will be familiar with the interface. It has some additional features not included in ChatGPT, such as being able to switch models mid-chat, conversation branching, voice control, and text-to-speech. And it also has a plugin system, which is how we were planning on using, implementing the interactive portion of ToxPipe. This is a vastly simplified view of how I've deployed LibreChat internally. Sorry. It's just a few small things to note. The user talks with the interface. The developer of LibreChat has also developed a small retrieval augmented generation addition to LibreChat where you can upload, it'll parse your Word, PDF, etc. It stores it there. All the conversations are stored internally on a Mongo database. And then I get access to all of the different models from all the cloud providers through Strides and proxy them through a light LLM proxy, which is nice because it allows me to give end developers a single API key and give them access to all of those different models with logging and tracing, budgeting, etc. So not only can they interact directly with the web interface, but they can also talk to the APIs directly. So in order to do those NTP reports, we've tried a few different tools, OCR, MyPDF, which has Tesseract as its underlying PDF parser. I've also tried Marker, which uses Surya as its OCR parser, and it is able to take and output markdown syntax, which is great for language models because that's a really easy way to interact with them. Some people have recommended Paddle OCR. Haven't gotten that one quite working just yet. We've also had really good success with Llama Index, which has its own PDF ingester and parser, and that's how we've been doing querying over the retrieval augmented generation. Cloud options are also available. The only problem is that they can get quite expensive. And just for the cost of embedding 5,000 PDFs from our NTP reports, probably about 10 to 15 gigabytes of data, we were using the Azure OpenAI API text embedding Ada O2 model, and my developer was able to get it working over the course of about 10 to 11 days. This is because we were hitting rate limiting issues with the OpenAI API. But this is just to show you for one of the most commonly used text embedding models currently from OpenAI, text embedding Ada O2. It cost us about $2,000 to parse 5,000 PDFs from those reports. And this is just a single embedding model. So without even comparing additional models, which we are going to do, there are some internal additional models that we wanted to test. And finally, just to wrap up how we've actually been doing the evaluations, we're using a tool called PromptFoo. This is a command line based tool. And then it has its own interactive web interface. But I have also been parsing out when you start using a whole bunch of models and different variables, the interface can get quite cluttered. So I've written a Python script to convert to a Quarto markdown format for our end toxicologists to evaluate. But the nice thing about PromptFoo is that it has both deterministic and non-deterministic metrics, which means you can either say stuff like, is the response in a certain format? Does it include in certain keywords? Or you can do a model graded rubric graded evaluation of the prompt output. So this is kind of how we've been approaching these tasks in general. So I'll end with that.